Okay, here's problem 9, and this is a no calculator question, so let's try and get through it without a calculator. Okay, show that the equation of L is y equals negative 4x plus 18. Okay, what is L? L is normal to the graph of f at the point 4, 2. And they give us a picture down here. So notice normal means perpendicular. So this is perpendicular to the curve. So what we can do is we can use the first derivative to find the slope of the tangent, and then the slope of the normal is going to be the opposite reciprocal. Okay, so to show that this is true, we actually have to find it. We can't just say, oh, look, it looks like it. All right, so what we need to do to find the slope of the tangent to the square root of x is we need to take the derivative. So we need to take the derivative. That gives us the gradient function. So to get the derivative, well, first of all, let's rewrite this as x to the 1/2. Okay, we like having exponents, not square roots. So the square root of x is equal to x to the 1/2. So I'm going to minus 1 from that and bring that down front. So 1/2 x to the negative 1/2. Now I can write that again with a square root. So I have 1 over 2, and then the negative brings us to the bottom, and the 1/2 makes it a square root. So there it is. There's the first derivative. Now I know that this point right here is 4, 2. They give it to me. And I therefore know that I need to find out what is the slope when x is 4. So I'm going to substitute in here a 4 for the x. So I get 1 over 2 times the square root of 4, which gives me 1 over 2 times 2, which gives me 1/4. So the slope of the tangent is 1/4. This is for the tangent. This is the slope or gradient of the tangent. But I want the normal. The normal is the opposite reciprocal, so the perpendicular slope is going to be negative 4. And see, oh, that matches. Okay, so now I have y equals negative 4x plus b. Now how am I going to find b? Well, I have a point. I have an x and a y that I can substitute in. So 2 is equal to negative 4 times 4 plus b. So 2 is equal to negative 16 plus b. Add 16 to both sides, I get 18 is equal to b. So therefore, y equals negative 4x plus 18. And we got it. Okay, and we showed how we got it. All right, point A is the x-intercept of L. Here it is right here. Find the coordinates of A. So to find the x-intercept, you set the equation equal to 0 because we want to know when is y equal to 0. So I'm going to make y 0. 0 is equal to negative 4x plus 18. I'm going to add 4x to both sides. So 4x is equal to 18. Divide both sides by 4. I get x is equal to 4.5 or 4.5, however you want to write that. Actually, let's go ahead and write it with a fraction. 18 over 4. Let's reduce that, divide both of those by 2. I get 9/2, which is the same as 4.5. Okay, so 9/2 or 4.5. So my x-intercept would be 4.5, 0. So this point right here is at 4.5, 0. Okay, now what do we got next? In the diagram, the shaded region R is bounded by the x-axis, the graph of f, and the line L. Find an expression for the area of R. Okay, so I want the area underneath here, but it's going to get cut off by this. So the way I look at this is if I wanted all the way over from 0 to point A, that would give me the area all the way to here. That would give me this area. And let's see, how did I do this? That would give me that area. And then I need to add on a little bit more area. I'm looking at how I did this. Okay, yeah. And then I want to, oh, I know how I did this. So instead of going all the way to here, I actually decided, you know what, I'm going to go to here. I'm going to break this area into 2 pieces. I'm going to find the area up to here underneath the square root of x. So from here up to here, the x value right there is 4. So what I did is I said I'm going to take the integral from 0 to 4 of the square root of x dx. Okay, I have all of that. Then I'm going to add to it the area of this triangle. Because see, it's just a triangle. So I could set up an integral for that, or I could just put plus the area of that triangle. The area of that triangle will be 1/2. The base from here to here, from 4 to 4.5, is 1/2. So 1/2 base is also 1/2 times height. And the height from here up to here, that's 2, because it's 2 units to go up to that point. So times 2. So there is an expression for the area of R. R is equal to that. Okay. I also could have done it with an integral, but I think this is like the simplest way. I can also simplify this, so I get the integral from 0 to 4 of the square root of x dx plus, what do we have? 1 times 1 times 2 is 2 over 4, which would be plus 1/2. So the area of this triangle right here is just 1/2. Okay, so this is the area of the triangle. So area equals 1/2 base times height. Oops, I'm off the side. That's how I got that part. Okay, so that's how I decided to break it up. All right. Do we actually have to find the area? Huh, funny. No, we don't have to find the area. Okay, instead, what they want us to do is the region R is rotated 360 degrees around the x-axis. Find the volume. All right, so we're going to find the volume. Now, to find the volume of this first part, I'm just going to do that first. So the volume is going to be equal to, from our formula packet again, remember it says the integral of pi y squared. Y is my function. So times the square root of x squared dx. And then I'm going from 0 up to 4. Okay, 0 up to 4. And then that would be this part. And the other part, notice that's a triangle. And a triangle, when I revolve that around the x-axis, I'm going to get a cone. So let me show you what I did on another piece of paper. I actually first tried doing this by making an integral. I took this line and I said I want the area underneath the line, and then I would square that, and I would times that, of course, by pi eventually. Put that off to the side, but I thought, okay, if I'm trying to integrate negative 4x plus 18 squared, I would need to put in a negative 4 and counteract it with a negative 1/4 because of the derivative of 4x plus 18. So I did my u substitution, blah, 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 and then I got this. And I was going, oh my God, this is crazy. This is like so much work that I'm going to have to do to try and find the area of this shape. So instead, I realized, okay, here's the triangle. If I rotate that triangle around the x-axis, I get a cone. So see the little cone that I sketched? Here's the base of the cone, here's its radius, and here's its height. Okay, from the pointy part to the flat part is called the height. So then I looked back over here and I said, okay, what's my radius? From here to here is my radius. My radius is the height right there, which is 2. And what's my that's the radius is 2. And the height of the cone, that'd be from here to here. Well, that's from 4 to 4.5. That's 1/2. I thought, oh my gosh, I can find the volume of the cone so much easier than I could do the integration. Because here, I'll show you what I originally did. Look at all this work. Okay, I was trying to integrate this. Look at all this. Holy moly. And then I thought, you want me to do this without a calculator? Forget it. So instead, I'm like, you know what? This shape is just a cone. So now, who remembers the formula for the volume of cone? Not me, but fortunately, it's on the formula packet. So volume of a cone is right here. Volume is 1/3 pi r squared times h. So I wrote that down right here. Volume is equal to 1/3 pi r squared times h. My radius was this distance, which I just showed you is 2. The height is this distance right here, which I showed you was 1/2. So if I multiply that all out, 1/3 pi times radius squared times height, I get 2/3 pi. Okay, so now I'm going to put that on my paper here. So how am I doing this? I'm going to add to this That's that area. I'm going to add to it the area, the volume rather, volume of a cone. So volume of a cone is 1/3 pi r squared h. And as I mentioned, this is 1/3 pi. The radius is right here. That's 2 units high. And h is the distance from here to here, which is 1/2. Okay. So this, if I multiply that out, I get 6 on the bottom. 2 squared is 4 on top. I get 4/6 pi. Okay, in the meantime, though, I got to do this one. Okay, so I've got here's the volume of the cone part, but now I need to find the volume of the other part. So I do actually have to integrate this, but fortunately this turns out to be really easy. I'm going to pull the pi out front from 0 to 4, and then I'm going to square a square root. What happens when I square a square root? They cancel each other out. So I'm left with x dx. Okay, does it get any easier to integrate? Not really. So that becomes 1/2 x squared, and I'm going to evaluate it from 0 to 4. So I'm going to plug in my 4. I have 1/2 times 4 squared minus, plug in my 0. 0 squared is 0 times 1/2 is 0, so that just goes away. 4 squared is 16. 16 times 1/2 is 8. So this is 8, and then the whole thing, oops, I almost forgot, the whole thing is times by pi. The whole thing is times by pi, so that's 8 pi. So I have 8 pi plus 4/6 pi, so my final answer is 8 pi plus 2/3 pi, because I can reduce that, and then those are like terms, they both have a pi, so I can add those together, 8 and 2/3 pi. So if you tried to do this problem and you tried to, do some sort of integral with this, it would have been really hard. So this is a lot easier if you break it up into the simple shape and the part that requires calculus. Okay, so the geometric shape, if you can find geometric shapes, use them. It's a lot easier than integrating. Alrighty, there you go.